Equations of lines. We have 5 objectives for this section. We're going to graph a line using its slope and y-intercept. Then we're going to use slope-intercept form to write equations of lines. We'll use point-slope form to write equations of lines. We'll write equations of both vertical and horizontal lines. And then we're going to find equations for parallel and perpendicular lines. So objective 1, graphing a line using its slope and y-intercept. Example 1, graph the line using slope and y-intercept points. Up until now, we have practiced using a t-chart. We have covered using x and y intercepts. And now this is a third method of graphing using slope and y-intercept. The first thing to keep in mind is that if you solve the equation and you have it in the form y equals mx plus b, then you can see the slope and the y-intercept points to use. Your b is your y-intercept, and your m is your slope. And keep in mind, slope is always in that form, rise over run. So anytime it's asking you specifically to use a certain type of graphing, in this case, slope and y-intercept, it means that it's going to specifically look that you use the points for the y-intercept and the slope one iteration from there. So let's start with our y-intercept. Notice our equation's already been solved for y equals, so we can see our slope and y-intercept here. So our y-intercept is this value right here. Make sure you keep an eye on the positive and negative. So it is a positive 3. That's our y-intercept point. And if we want to write it as an ordered pair, remember y-intercepts are always in the form of 0, comma, whatever your y-intercept is. So in this case, positive 3. So 0 meaning we don't go anywhere left or right. 1, 2, 3. That's our first point. That is our y-intercept. From there, we want to do our slope. And that is our value here, 2 over 3. And I'm going to write next to it the rise over run. That's the reminder of how we move with this slope. So if it is not a fraction, you can always turn it into a fraction. But make sure you have it in fraction form, and that will help you see how much you need to go up or down for rise and how far to the right you need to go for run. So since this is positive, we are going to go up to 1, 2, and then we're going to run to the right 3. 1, 2, 3, and that's our second point. Connect the 2 points together into a line, and that is us graphing using our slope and our y-intercept. So again, for grading purposes, we are specifically looking for these 2 points to be clearly marked. Let's try this again. Example 2, graph the line using slope and y-intercept points. The big difference from the first example to now is notice this one is not solved for y equals. In order to use our slope and our y-intercept, we want it to be in that form y equals mx plus b. So our first step is we want y to be by itself. So go ahead and subtract or add, move anything around that you need to get your y by itself. Make sure if you have to do any dividing, you do that as your last step. And then once everything is set equal to y, then we can pull off our slope and our y-intercept. So our y-intercept is right here. It's our negative 3 this time. So that's 0, comma, negative 3. And then our slope is this negative 1. Now it's helpful if you go ahead and put that into a fraction. So any whole number can go over a 1, and that will help you with your rise over run movements. So since the whole thing is negative, I tend to put the negative on the top to remind myself for a rise that we are going to go down 1 And then our bottom one is always going to run to the right. So we're going to run to the right one. And that's where we're going to put our second point. And then we can connect our two dots together and we have this line graphed. Objective 2. Using that slope-intercept form, we'll write equations of a line. So example 3, write the equation of line with the y-intercept 0, -4 and a slope of 2/3. So again, slope-intercept form is that y equals mx plus b. So that is what that's called, slope-intercept form. Because when you glance at it, you can easily pull off what is our slope value, what is our y-intercept. So notice they gave us specifically the y-intercept here, and because of the ordered pair here, 0, -4, our y-intercept is -4. So we're going to put in -4 where the b goes. And a slope of 2/3 means that we are going to put in for the m 2/3. So y equals 2/3 for our slope, our variable x, plus a -4 for our y-intercept. Now I added and then I put the negative number. You could leave it like that, or you could switch that to just being a -4. Either one works. Objective 3, using point slope formula to write the equation of a line. Now, we've used slope-intercept, which is this format, y equals mx plus b. And we just saw with our last objective how easy it is when you're given the y-intercept and the slope to just drop it right into the equation. The problem is we're not always going to give you that perfect y-intercept. We may give you a different random point. So this is where point slope form comes from, is the fact that I can give you any point, not just your y-intercept now, and your slope, and you can plug it in and simplify it, and you have an equation of a line. So what this looks like is y equals m x minus x1 plus y1. Now, this is absolutely an equation that you need to know for this chapter and this section specifically. You have to know this one. But let's break it down and make sure we understand all the parts in here. The m stands for your slope. The x1, y1 here, this is your any point that you can plug in. So x1 meaning it's that x value from your ordered pair, y1 meaning it's the y value from your ordered pair. And then this x and this y do not go anywhere. They do not get substituted out. So those are just part of your equation, just like here with our y and our x when we're in slope-intercept form. And the nice thing is with this one, once you plug in any point and your slope, this one then will simplify into this format for you. So these two work together. They are not like two different things. It's just like an expanded form. That way that we can use any ordered pair we want. Let's put it into action. It says, for example 4, find an equation of the line with a slope of -2. So that's our m. That passes through the point -3, 5. That's that any ordered pair, so x1, y1. Write the equation in slope-intercept form, y equals mx plus b. Now I'm going to underline that y equals mx plus b because that's just the final form we want our equation to be in. That is not at all where we are going to start. So we will come back to that y equals mx plus b later. First things first, because we have any random ordered pair and a slope, we need to use our point slope formula. So the fastest way to learn any formula is to write it before every time that you use it. So write it with all the variables, then go back and start plugging in what we have. So we've got -2 for slope, we have minus, and then we have a -3. So a minus minus is going to make a +3 in there with a +5 out back. We can distribute and combine like terms here. So I'm going to distribute that -2 into our parentheses. So -2x minus 6 plus 5 from the back. We can combine like terms. Y equals -2x minus 1. And notice just by simplifying, we got our answer in that final form they asked for. So that's the really nice thing about point slope, is it will simplify into slope-intercept form. So we are good to go on example 4. Example 5, write an equation of the line through the ordered pair -4, 3, and 2, 6. Write the equation in standard form. So standard form is how we want the final answer to look. So we'll come back to that in a moment. We don't have, between either of these ordered pairs, we don't have a y-intercept. So we know that we're going to need to start with our point slope formula. And I have a point, but notice that we don't have a slope here. We don't have one yet. We do know how to find a slope from a previous section. y2 minus y1 over x2 minus x1. And I can label my ordered pairs. The subscripts just help keep us track of first ordered pair and second ordered pair. And I can plug them in. So we have 6 for y2 minus 3 for y1 over 2 for x subscript 2 minus a -4 for x1. We can simplify on top. On bottom, make sure you recognize that a minus minus right there is really just a plus sign. So 2 plus 4 gives us 6. Anytime we have fractions, always check to see if you can simplify them. This is your slope. Now that we have slope, we can do our point slope formula. We can plug in 1/2 for slope, x minus, and notice once you get to the point where you need to plug in x1, y1, you could use either ordered pair. I tend to go back to the first ordered pair ever given, just because I already have it labeled as my x1, y1. That just works well for my brain. So -4 makes this a +4, +3. Then I can distribute. I get 1/2 x plus 2, bring down our +3, and I can combine like terms. We'll move it up here. 1/2 x plus 5. So we are essentially done with the problem, but a lot of this section is going to be switching back and forth in how they want your final answer. So this problem specifically said at the end to write the equation in standard form. Standard form is ax plus by equals c. So I need to get both of my variables x and y on the same side. I need my x variable to be positive. And I need my a, b, and c to have no fractions. So we want to clear out any fractions for a, b, and c. All right, let's see what we can do. Let's move a couple things. Let's move y over here, and let's move 5 over here. So that ends up with -5 on the left, 1/2 x minus y on the right. Notice that we have both x and y on the same side now. Move it up here so we have more space. And when I do, I'm going to go ahead and switch the sides. Notice everything on the left is, or on the right is now on the left, and everything on the left is now on the right. I didn't change signs or anything, we just got it switched around. The only thing that I still need to do here is I do need to get rid of this fraction in the front. So because it is a 1/2, I'm going to multiply everything by 2. So I get x minus 2y equals -10. This is what we're talking about for standard form. Notice my x and y are both on the same side. Notice that first term, my x term, is positive. Notice the a, b, and c, the numbers in here, have no fractions. We have cleared those out. This example 5 represents like the longest problem you will have in this section, because we asked you to find the equation of a line, but in order to do that, you had to find the slope and then use your point slope, and then you had to check that you were in the right format for your final answer. So this is like the most involved problem you will see. Example 6, write the equation of the line graphed. Write the equation in standard form. So again, we'll come back to that standard form at the end, but let's start with this graph. Instead of giving you 2 ordered pairs like the last problem did, they're giving you a graph, but you can find the ordered pairs. So the easiest way to pull something off a graph is find the best spot where like the line is crossing like right in one of those little corner spots so you can get a perfect ordered pair. So if I start from the far left, I like this one right here. This one is -4, 3. That's a very nice clear spot where it intersects like one of these little corner spots. And then if you keep on going, notice this one's also a really nice one right there. -1, 4. And just looking ahead in case you found a different one, let's see. This one's a nice one, 2, 5. And then right here at the edge, 5, 6. Any one of these ordered pairs would work great for this problem. So you can pick any 2 ordered pairs and find your slope. But I'm going to shortcut that by saying if I have my graph, I can just count out my slope, because I just need one of these ordered pairs, and I'm going to use this one because it's positive. It had nice, pretty numbers in it. So I'm going to use that as my ordered pair to use. And for my slope, if I move from one of these points to another, I need to recognize, remember, the rise over the run. So if I start on this far left point, I need to go up 1, rise of 1, and then I need to go to the right 1, 2, 3. That's my slope, 1/3. And you can repeat that from each one of these points, from one to the next, all the way through, and you can see that repeated. So now that I have a slope and on any ordered pair, I can use my point slope formula. I can plug in my slope, the 2 for the x1, the 5 for the y1. I can distribute. I will need to combine like terms, but before I do, because I see that if I do that, I'm going to have a whole number and a fraction. I'm going to need common denominators. I'm going to make a quick little shortcut here because I know that this final thing needs to be in standard form, which means that I can't have any fractions at all. So I'm going to go ahead and clear my fractions right now. I'm going to multiply everything by 3 to clear those fractions out. 3y equals x minus 2 plus 15. That's going to make my life a little bit easier. because now I can do 15 minus 2 to get 13. I need to move my terms around, so I'm going to move my 3y to the right, and I'm also going to move my 13 to the left. And then just for my final answer, I'm just going to switch the sides. X minus 3y equals negative 13. This is standard form. I've got both my variables x and y on the same side. My x term is positive. There are no fractions in here. Example 7. In 2005, Window World Inc. had 40 employees. In 2022, the company had 85 employees. Let X represent the number of years after 2005, and let Y represent the number of employees. Part A, assume that the relationship between years and number of employees is linear. Write an equation describing the relationship. So if we need to write an equation, we need to see if we've got some ordered pairs in here. So if we go back to the wording of the problem, it tells you what to use for X and what to use for Y. So X is the number of years after 2005, and Y is going to represent the number of employees. So the first set I have 2005, which would be 0 years after 2005. We had 40 employees. And then in 2022, let's see, that's 17 years after 2005. I subtracted them. 2022 minus 2005. We had 85 employees. So if we're given two ordered pairs, the first thing we need to find is slope. So our slope formula is y2 minus y1 over x2 minus x1. We've got 85 minus 40 over 17 minus 0. 85 minus 40 is 45 over 17. And it's not a super pretty number, but that's okay. And there's nothing else that we can simplify or pull out of either, so we're going to leave it just like that. So we have our slope, and I need to write an equation. So we could use point slope, but I recognize way over here, this 0, 40 is our y-intercept. So I have slope, I have y-intercept. We can write this equation right now as y equals 45 over 17x plus 40. It went right into that y equals mx plus b for us. Again, that one's your y-intercept there, that 40, which worked out really nice. Part B, use the equation we just created to predict the number of employees in 2018. Now keep in mind, X represents the numbers of years after 2005. So we need to find the difference between 2018 and 2005. And that's the X that we're going to plug in. So we're going to be plugging in 13. So Y equals 45 over 17 times 13 plus 40. Now we're going to plug this into the calculator. It doesn't make very nice numbers. So we're going to go ahead and multiply first, get an answer, then add the 40, and we end up with 74.411, and it keeps on going, a long decimal value. And then just always make sure when you are plugging in on any computer system that you always check to see how many decimal places or what format your final answer should be in. Objective 4. Write the equations of vertical and horizontal lines. Now we know both our vertical and horizontal lines are only going to be defined by one variable. So just as a quick reminder, a vertical line is always x equals a number, and that's where it is crossing your x-axis. And your horizontal line is always y equals a number, because that's the location where you are crossing your y-axis. So they are defined by their intercepts. So for example 8, we really have two questions here. The first one says, write the equation of a horizontal line. So mentally you should think, what does a horizontal line look like? I know it's going to be y equals. And then it's containing the point -2, 3. So all we need from here is that y value from the ordered pair to create our equation. So you might be thinking to yourself, wait, that's it? It really is. Our horizontal and verticals are just pulling off the x or the y value that was given to you as the point. Now, the ways that we can switch this up on you is instead of saying horizontal and vertical, we could also define these lines by the type of slope that they have. So let's look at the second one here. It says, write the equation of a line containing the point 5, -6 with undefined slope. So you would think to yourself, okay, undefined slope, that's when it's that straight up and down, because you can't walk up a wall, example that we had. So if it's straight up and down, that means it's vertical. And verticals always are talking about our x value. And in this ordered pair, our x is 5. So our vertical line is x equals 5. Objective 5. Finding equations of parallel and perpendicular lines. Example 9. Write the equation of the line containing the point -2, 4, and it's parallel to the line x plus 3y equals 6. Write the equation in slope-intercept form. So we have the ordered pair, x1, y1, and instead of just telling you the slope, this time it told you it's in this other equation and they're parallel. So keep in mind, parallel means same slope. So we want the same number, same sign, the whole package. So what we need to do is we need to take this equation over here and we need to write it off to the side, find the slope within it. So in order to find the slope, we need to get this into y equals format. So we're going to move our x over. We're going to divide 3 from each of our terms. And then once we have it in y equals form, we're going to pull off the slope. So in this case, it is the slope -1/3. And we have the ordered pair, -2, 4. And again, because it is parallel, we are going to use -1/3 as it is. So now we have our point slope formula. We're going to plug in our slope, our x, our y, and now we can start to distribute. Y equals -1/3 x minus 2/3 plus 4. This is always the moment where I pause and kind of go back to my directions just to see the final form they want. And they do want it in this slope-intercept form. So the last thing I need to do is just combine these two terms over on the right. Now keep in mind, with a fraction and a whole number, you do need to get common denominators. So I'm just going to pull this off to the side for a minute just to refresh our memory right here. Off to the side, -2/3 plus 4. but I want 4 instead to be something over 3. So if I multiply it by 3, notice that we get 12 over 3. 12 divided by 3 is just the whole number 4. But now I have it in terms where they both have that same denominator, 3. And then 12 minus 2 on top gives us a positive 10 over 3. So y equals negative 1/3 x plus 10/3. And we are in slope-intercept form. Example 10. Write the equation of the line containing the point 3, negative 5. And this time we are going to be perpendicular to the line from 3x plus 2y equals 7. And we are going to write our final answer in slope-intercept form. So the first thing we need to do is we need to take this equation off to the side. 3x plus 2y equals 7. And we need to find our slope. So we're going to solve it for y. So we're going to subtract the 3x from both sides. And then we can divide everything by 2 to get y by itself. And then we're going to find our slope, which in this case is negative 3 over 2. But I don't want a parallel slope this time. We want it to be perpendicular. So keep in mind, perpendicular means that they are opposite reciprocal. So opposite meaning we are going to change the sign, so from negative to positive. And then reciprocal means that we are going to flip the fraction. So instead of 3 over 2, we're going to have 2 over 3. So now we have a new slope. We are going to use this ordered pair, and we can put both of those together into our point slope formula. Two-thirds for slope, 3 for our x, and negative 5 for our y. We can distribute. Again, we want it in slope-intercept form, so now we can combine like terms on the right. Negative 2 minus 5 gives us negative 7.